Hello, so today we're looking at geometric sequences. All right, so first, what is a geometric sequence? So a geometric sequence occurs when there's a multiplicative term involved. So terms are changing by multiplying values. So for example, in an arithmetic sequence, we're adding a value to the previous term. So for a geometric sequence, we're multiplying something to the previous term. Okay, so for example, say our first term is 1. We're going to multiply by, say, 2. And then we're going to multiply the 2 by 2 again, and then again, and then again, and again. So we're just multiplying by 2. So this is a geometric sequence. Our general term is a times r to the power n minus 1. So a, in our case, a is our first term. R is what we're multiplying by, which is 2. A recursive term is the previous term times our R value. So, for example, how do we get 16? We get 16 by multiplying 8 by our R value 2. Okay, so with this in mind, let's have a look at what we're being asked to do today. For the following sequences, determine the initial term, the factor by which each term changes. So our multiplicative term R, the general term, and the recursive term. So let's write out a form for our general term and for our recursive term. Okay, so in part 1, A equals 2. Part 2, A equals 1. In sequence 3, oh wow, we have quite a few here today. A equals 3, sequence 4, A equals 1 again, and sequence 5, A equals 2/3. All right, so in sequence 1, what is R? R equals, looks like we're multiplying by 2. So we looked at this example. It's nice. Now in sequence 2, what are we multiplying by? It looks like we're multiplying by 1/3. In sequence 3, wow, looks like we're multiplying by -1/2. Sequence 4, we're multiplying by 5. And finally, in sequence 5, what are we multiplying by? It looks like we're multiplying by 2/3. Okay, so we have all this information. Now let's write out our general term. So our first sequence, our general term is A times A times R to the power n minus 1, or in this case, 2 to the power n. Just adding our exponents because we have the same base. All right. Second sequence, Tn equals A, which is 1, times our R value, 1/3 to the power n minus 1. Right, third sequence, A times our R, which is -1/2 raised to the power n minus 1. Third sequence, Tn equals A, which is 1, times R, which is 5 raised to the power n minus 1. And our last sequence, we have T to the n equals our A, which is 2/3, times our R value raised to the power n minus 1. And this works out to be 2/3 raised to the power n. Good. All right, and finally, let's look at our recursive terms. So T n, or nth term, equals r times our previous term, so 2 times t to the n. Second sequence, tn equals 1/3 t to the n minus 1. Third sequence equals -1/2 times our previous entry. Sequence 4, we get t to the n equals 5 times t to the n minus 1. And our fifth sequence, our final one, t to the n equals 2/3 of t to the n minus 1. Great. That brings us to the end of our session. If you have any questions, send us a note to info@raisemymarks.com or give us a call day or evening, and we will be happy to answer your questions. Thank you for watching, and see you soon.